Didn't have my chat window open for some reason. Why not? I don't know. It's a mystery. How am I today? I'm doing pretty well. Getting ready to program. Saved from the mediocrity of browsing Reddit. Well, you know, it seems likely to me that you are capable of saving yourself from the mediocrity of browsing Reddit at any time, should you so choose to do that. I mean, I'm not sure, but I think so. I think it's possible. Have I ever implemented linear optimization by Lagrange relaxation with subgradient optimization? I have not. I have done a little bit of energy minimization stuff. Not a whole lot. I've done things like, in fact, I put this in a magazine article once. I did like find a dictionary of evenly distributed unit vectors on a sphere, which is a relatively trivial energy relaxation problem, but one that has practical use. What's today's agenda? It's just like it totally says in the title. We're working on the movement transaction system. Do I plan on playing with braid style time rewind more? Not anytime soon. I don't really know what I would do with it. So yeah. What good is that? What good is braid style time rewind? Enigma is really good. Highly recommended. I am currently stuck on a puzzle, but it's a good game from everything that I've seen so far. They always get to Galaxy Brain before the end. This one... I don't think it's as hard as Vexed Edit, for example. I might be wrong about that. There were a couple things that were a little bit hard, but it's not super hard, although I am stuck on a puzzle right now, so maybe that one is super hard. I don't know. Is it already running on the PlayStation? No. No. Did I say Vexed Edit? Yes, that is the name of a game. It is a video game that you can play. Glad you appreciate the talks and rants and streams and all that. Right on. How many decibels would you have to pay to write a good text editor? You know, I may end up writing a text editor at some point. Obviously, I've got too many things happening right now. But once some of it chills out, like it wouldn't be... So to write a text editor just for myself would be pretty easy. honestly. The only annoying part is like, do I support non-Latin character rendering? Probably I would try to do that. And then you just need to like line up fonts that have all the characters that you're likely to see. That's the most annoying part. Like people rat hole on text editors on things that do not matter because again, they don't understand how fast computers are. They're like, oh, am I going to store the text lines as buffer gaps or ropes or whatever? And it's like, look, none of that matters. It's completely irrelevant, bro. The things that matter actually in terms of performance are different than that. Do I use evil mode? No, I don't even know what it is. You've heard the good things about 4Coder? Well, so did I, and then I tried it and I couldn't use it. So, yeah. What would be a standout feature? I would know how to expand its functionality without having to rat hole on stupid Lisp stuff for days. That would be, for me, that would be what I would care about. Also, it would be fast. Would it make sense to implement a user checkpoint system? What do you mean by user checkpoint? Do you mean just like, here's a place that I want to go back to if I hit reset? Yeah, something like that might make sense. We still have to figure out. We want the undo system to be better than it is right now, but we haven't thought too much about what exactly that means. Text editors have to be the #1 bike shed topic in programming history. Accurate. Okay. So, every time you start the X server, it goes through a shutdown sequence and turns off. I am not surprised in the least. Okay, so I got rid of the annoying turning problem that we had at the end of the last stream. Mostly, oh, well, not completely, I guess. That's a data problem. We're going to have to, I think it's a data problem. Anyway, for the most part, we're okay. The thing is just, we don't really have acceleration right now. Which honestly, I'm not sure I miss it that much, but I want to put it in. It probably helps a little bit. Anyway, we can do basic turns like this now, and they work. Okay, so the way this transaction system works, if I'm like pushing something, you know, the whole point is that me and the rock move at the same time. Now, like we physically move at the same time from square to square, in addition to visually moving. So we need to maintain that physical moving. We also kind of want to sync the rock visually to the guy's motion. And we probably want to adjust the transaction time. So right now, when I move a square, we're just saying this is how long a push is, and then we're just calculating the speed based on that. And the problem is it's not that simple if you're accelerating, right? So we probably want to look at what speed you're going, what speed you will be at, and what speed you will be at can be calculated by the same variable that we're doing right now. So we figure out what your speed you're going, and then we figure out the acceleration curve, and we can like clamp it to be so that you'll accelerate faster if it like would take too long for whatever reason. Like if you're turning around, like if you're going in the opposite direction and want to come back, we don't want you to take forever to, yeah. The point lights come out. They're fine. There's still no shadows, though. Okay, so we're going to have some kind of a ramp to full speed, right? We're just going to say for now that takes place over a fixed amount of time, right? So then we need to cover 1 unit of distance, right? So the distance covered by the ramp up, if it's a linear ramp up, right, is 1/2 times the velocity max times the time, the acceleration time, right? And then V1 times T let's call it constant speed, t const for constant speed, right? And that equals 1 if we're traveling 1 square. So we just solve for t const if txl is given, right? So t const equals 1 minus 1 half v1 txl divided by v1, right, which is 1 over v1 minus 1 half txl. That seems a little bit simple, but maybe it's kind of reasonable. I mean, really, that 1 in the 1 over v1 is the size of the square. We're just locking it at 1, right? Looks like the units are correct. Draw it in paint. Nah, not worth it. How does quickly going the opposite direction work when you push a block? Well, even for acceleration. So if we add acceleration in on the guy, we're going to have to copy that information to the block in some way, or it's going to be messed up. And it may be messed up in the beginning. We may want it to be a little bit messed up. Like we might, for visual purposes, want him to go into the block a little bit before pushing it, you know, just a little, and then IK it. But that's a touch that we could do later. Anyway, so that's the duration. So then the duration of the transaction actually. So that's t const equals 1 over v1 minus 1 half txl. The duration of the transaction is actually t const plus txl, right? Which is 1 over v1 plus 1 half txl. So if v1 is 1, that doesn't make any sense. Wait. Just as a sanity check, if v1 is 1, that means we would get across the entire block at constant speed in 1 second. If there was no acceleration, instead it becomes 1 second plus a half t. Okay, that makes sense. I don't see anything egregiously nonsensical. Yeah, always look at your equations and try to interpret what they say after you think you did. Even if it's simple math like I just did, just try to understand what they say, and that'll tell you if you're being stupid. Okay. So now I have to find the place where these things, do I still have a print? Okay. We've got to find the place where this happens. Probably here. Move individual guy. I need to factor all the moving stuff into its own file at some point. Okay, so we make a transaction. And then I forget, how do we decide the duration of the transaction? When we close it, okay, we just look at the duration of each single move. So that's fine. Okay. I thought I had a thing called get move info. We do. And that says, hey, it's a linear move, and so forth. And then it overrides that with teleports if it's a teleport. Okay, if it's not a teleport, if it's a linear move. Oh, and then I think this will get copied to all the stones and stuff. So for now, we're just going to assume velocity starts at 0, which is something that we could change later. So that's if it's a teleport, whatever. But down here, we're going to say, we're just going to hard code like info.excel time is, I don't know, O.2. All right, we're going to say what did we just say? We're going to say that's txl. Let's we're going to say v1 is just this. That's what we said, right? And then the duration is going to be 1 over v1 plus that. Now, anytime you divide, you got to be careful, right? It's just, you know. So we do the duration. And that's it. Later, we're going to want to put what the dude's velocity was to start and like maintain that. But for here, we're not yet. We just want to see him accelerate. Okay, and then here, well, we'll say if mover is just if it's a guy. All right, so we got to go to the move info and add these fields. We'll say Excel time and I guess that's it. Let's set, wait, V1 is 1 over this. Oh, wait, V1 is 1 over this. So 1 over V1 is just the duration. All right. Let's call this, and then like that. There we go. Okay, so we have some amount of time it takes to move. This is the speed Now we don't need that for our little equation anymore, but we want to put that into here. All right. Okay. Okay, so now when we move, okay. So we're calling this update guide position. And we're going to say this is only for an accelerating move. Otherwise, if this is -1, we're just going to go through this old thing down here. All right, this run speed. I'm not sure. I mean, I guess that duration we were figuring out before was totally being ignored. That's what happens when you revise things over time. So I'm going to put on my list the run speed needs to get used. Okay. So we're figuring out the delta. We actually don't need to do that. That should be in the single move now. Yeah, it's delta. Let's factor that out. And let's put this back to 0 for a second and make sure that we didn't break something. Excel time. It's not a member of single move. No. Move info. Move info. Max, undeclared, oh, because it's not capitalized. In this code base, and then run speed. So this part now is just that I took out the run speed thing. Let's put it back for a second. We're about to take it out again. Okay. So now that the block is going faster than me, because it's just getting different movement information. But all we're testing right now is that the guy still moves linearly correctly, which he does. Because, you know, we're testing this part where we use this delta instead of recomputing it, and that's fine. I'm in the wrong category. Oh no, you're right. That is true. You can't just categorize me like that, man. I'm a human being who accidentally melted his chocolate bar by putting a hot tea thing on top of it. What is a movement transaction system? Well, I explained this whole situation in detail at the start of the first stream. So anyone who is tuning in and doesn't know what's going on, which is probably a lot of people, there's like a 15-minute explanation, and you can go back to the VOD and follow that up. Did I anticipate the movement system to be such a time-intensive part of the game? Probably not. Probably not. I probably thought that the interaction of the different gameplay rules was going to be the hard part. And it really wasn't. I mean, that's sort of, the interaction of the gameplay rules is what makes this so complicated, because it needs to handle so many things robustly. But it really is the movement system that's complicated, not the gameplay rules. Twitch thinks I'm still streaming Enigma. I hit the button, man. I don't know what else it wants from me. Does no check-in get flagged in a commit hook? Yes, it will not let me commit until I remove that string. Okay, all this stuff about falling or dead, I don't think is relevant. This is all like super old. We're not going to do deceleration. Yeah, this whole, oh God. So right now we're trying to figure out how long the move is going to take. And estimate, and the reason that's important is we estimate the transaction time. Although I guess deceleration, mostly would happen after you moved. So, so it doesn't affect the part of this that's touchy. But we're just going to comment it out for now anyway. But for now, we're just not even doing that. Okay. And in fact, all of this is going to go there. And then it's a little bit dicey to use this variable on the guy. Okay. So we're just going to say there's a desired velocity which is just the delta times the target speed. So this is a little bit weird because we're not directly evaluating the same thing that our equation was saying before. Our equation just broke acceleration up into two things and then said there's this period and that period. And we're not exactly doing this. But that's okay because I think we want this to be able to get more complicated. And this is just an approximation that has to be close. So we'll see what happens. We could always, if we factor this out into something, we could always just run this for 20 time steps to approximate how long the move will take if this becomes a complicated function. That would be interesting. So the reason I put velocity over here instead of using it on the guy is because I want it to start from 0 every time so that we can see the acceleration always happen and we can yeah, I guess accel time is not really necessary. Anyway, I feel like I'm forgetting something, but I'm also not in the mood to think that hard. Target speed. Declared identifier dv. So that would have just been so that controls our acceleration speed. How much do we accelerate? And okay, that's where the time step would come in actually, because, right. So we are going to use this. Okay, so we're going to say dv is 1 over accel time. So that's how much acceleration we would get per second in units of acceleration, right? And then times dt. Right? So this is how much velocity we would accelerate in 1 second. Times dt, that's all. Keep making the same mistakes. Keep making the same mistakes. All right, I probably really messed that up. Acceleration per second is called jerk, but that's not what that was. That was the opposite. That was how much acceleration would you integrate in 1 second. Okay, this looks like he's actually slowing down. That's a problem. Wait, what? Or we're just going to start printing some things out. Look at all these animation messages I've still got from that previous string. Oh, we have some renaming we want to do there. Okay. Get rid of some of those print statements. It's not that we don't in general move across diagonals, we just don't move across diagonals. Okay, so what do I do? I'm just going to say I'm going to print the desired velocity I'm going to print and we're going to see what happens over time. See, this is where printf debugging is good. Like print debugging is not good in many cases. Like if you just want to see values of variables, it's much better to run a debugger. But like when you want to see a bunch of stuff over time and you don't have a convenient graph for it on the screen, which probably we should make, honestly, you know, print at least tells you stuff over time. Okay. Desired velocity is, well, it's constant, right? And v is indeed going up. But it never even gets to max velocity. And then we probably run out of time. Or something, right? Graphics got darker. Yeah, I mean, it's supposed to be a dark level. Okay, so Excel time here is being interpreted wrong. I don't know if this is the only problem, but Excel time is being interpreted in this math as the time to accelerate 1 unit. And it's supposed to be the time to accelerate to max speed. So it should be this. That's still not going to fix us all the way, I don't think. But it should help. Oh, well. I mean, maybe. Rock's still going much faster than the dude. That's fine. We handle that later. He's just got magic force powers by which he pushes the boulder away. So you can see that the acceleration is happening now. So if I hold to the right, you'll see he no longer moves in a smooth line. He like, it's jerky, right? See? And so if we make the accel time longer, we should be able to right? Didn't we use the default? Get move info. Info, not Fino. No, we hard coded it. Let's use move accel time default. All right. Okay, so we didn't break it. And then we'll go over here and we'll say 0.5. So you can really see him taking more time to accelerate. I don't think we want it to be that slow in the actual game, but that's fine. And then the question is, I mean, the animation doesn't really look right anymore with that much acceleration, but yeah. He feels really soupy to move with this much acceleration. The rotation problem is fixed. Mostly. It's a little bit annoying. It has to do with the way that we control rotation, and I'm not sure what's a good fix for it. So then the extra fast animation that's happening here is I'm just getting impatient and slamming the key. And when multiple moves are buffered up, we make time go faster for the player. And it's very easy to buffer multiple moves up because my moves are so slow because we're taking half a second just to accelerate to full speed. All right. But yeah, you can see him stopping to 0 each time. So that's what we've been trying to do. Let's make it not quite as annoying. Let's go 0.3. Okay. So it's still clear that that's working. It's a little bit, again, it could be kind of hard to track with your eyes because the movement of his arms and all that, but you can see what he's doing. Okay, so that is all fine. Now, though, we don't want him to accelerate if he's already at speed, right? We want to track a velocity on the player and use it. Now, we have a velocity variable stored on the guy. And so I think we copy that over to the move when you start moving, maybe. Or maybe we leave it on the guy. Maybe we leave it on the guy. That's the way it used to be in the old movement system. So, you know, we had, if I go to our entity definitions, oh, it's in the base, so it's here. We have this velocity thing, which I said, oh, remove because we're not going to use it, but maybe we are going to use it. Maybe I make a new one. Oh, maybe not. Because, you know, when I first started making this system, I was like, well, maybe everything's going to be kind of physicsy, so everything's going to have a velocity. But, you know, maybe not, right? So maybe instead, what happens is only guys have velocity. Guy includes the female characters. It's just a class called guy, or a struct called guy, an entity called guy. So I could just put this on there because we don't want like rocks and stuff to ever accelerate on their own. There are other entity types that do accelerate. But I don't know if it's worth spending this for every entity in the game, you know, this storage. So I'm just going to put it on the guy. I'm going to leave this one here. We're not going to use it though. The thing is, this is in all the save files right now, so we would have to go through a bit of a process to actually remove it. But for clarity, to make it clear that we're not using this for most things, I'm going to make a new field, which actually seems more wasteful, on here. And 12. We're just going to say velocity is a vector 3, version 12. There we go. And instead of here, I'm just reminding myself to delete that line. Instead of there, oops, let's, oh, I forgot that I have this Emacs binding. I was like, what did I mistype? If I can, whoops. Oh, that didn't, hold on. Okay, that didn't do what I thought. Never mind. .targ, what was it? Target speed. This is why I don't want to use Emacs anymore, man. All right, so, okay, instead of using this velocity on the move, we are going to use it on the guy. Oops. Okay. And we're going to put it there. Now, that's all fine, however. Okay, now if I run around, it should be smoother. But the problem is I'm not using this velocity when we compute the transaction time in the beginning, so that's going to be off, but you may not see it be off. Whoa, okay. Well, that's, okay. When he stops, we're not ever clearing the velocity. See that? So when I turn around and go the other way, he's got like residual. So that's not good. Or like if I go sideways now, he'll like go left, right? Whoa. See. And then now he's like completely a square off from where he thinks he is. Yeah, so that's interesting. Okay. Let me get some iced tea, and I'll be back in a second. So the version 12 thing that someone was asking about just says that that's the current version of the entity. Let's go back there for a second. This is the current version of the entity, right? This thing was added in version 12. So if you ever find any of these entities in save files and they're before version 12, don't try to load this. And with very simple mechanisms like this, you have backward save file compatibility. And so for games that mess that up really badly, there's not really an excuse. Which, by the way, is a lot of games. Okay. So right now we have this big drift now between where we end up and whatnot. And that's because we're starting with all this velocity and then we're killing the transaction at a certain time. Like, when do we say it's done? So there's multiple separate issues here. Right now, I think a transaction ends when its time is complete. And that transaction can be a series of moves. Like if I'm pushing a bunch of boulders, they all have moves, right? But we kind of don't want that, because as soon as you're responding to like velocity and all that, then it's more like you want the transaction to last until you reach the target point, right? And so the reason that we're desyncing here is that the transaction isn't being allowed to complete all the way. And so we end up, like, we just stop it and we go to idle, and so we end up not quite in the square where we're trying to get to because of this extra acceleration, right? So we have two things to fix. One is that extra acceleration, but maybe before fixing that, it is better to give ourselves an adverse situation to deal with and say, well, the transaction doesn't complete until you get to where you're going, right? Now, you might say, well, doesn't that defeat the whole purpose of having these transactions computed in advance? And the answer, I think, is again, no, because the thing that needs to be computed in advance is the time of the invisible physical transaction that occurs. And that has to be pretty close to the visual time. Okay, so we actually have three things that we have to do. So time computation still doesn't use that initial velocity. So that has to happen. We should actually debug show transaction time. We should show somehow when the actual transaction clicks, because right now we're just taking it on faith that it's happening at a good time, and we don't really have a sophisticated enough situation set up to really test that, and we don't want a rat hole on that. But if you can just see a message that goes, the transaction happened now on the screen, then that's pretty good. But we're not going to worry about that yet. We're going to worry about these obvious visual problems like transaction completion and What was the third one? Oh, then we need the 0 hour velocity when not moving. Okay. Could I add transaction info on the animation debug panel? I could. I don't want to do that right now, just because I have a meeting at work at 1:30, and also I'm lazy about programming visual tools. Okay. So let's do this thing where the transaction lasts as long as it needs to. But not always, because some transactions won't be driven by an acceleration like this. Although maybe... So right now, the way that we end a transaction is just when elapsed reaches duration, right? Let me find that. Where do we call? Well, so here it's like, hey, figure out if you're going to physically move, figure out if supporting things are going to update. Based on the physical moves. Those aren't visual supports. Those are the invisible physical supports. Where do we complete here? Okay, so we call update move transaction for each individual one. We maybe kick the undo system to save state here. Where does completed happen? Oh, yeah, right there. Okay, so if the transaction's done flag gets set, we add it to this completed array, right? And then down here, we iterate over all the completed things, and we do stuff that might need to happen. Like if a rock is going to skip off water, we don't do that until its transaction completes. Or if something's going to fall off a ledge, we don't start it falling. And then we see if there's any buffered keystrokes that should start new transactions. And then we do animation responses to our transactions. We were fiddling around with this a while ago. So this done flag okay. It's just set if elapsed is based on duration and if we have physically moved. So we want this to actually get more complicated. And I guess I'm going to add an extra flag. I'm going to say if t dot driven by a controller, we do something, right? And what do we do? We're going to look for we're going to look for our moves. If we don't have any moves, we're done for sure. I'm not sure why that would happen, but somebody might steal a move away from us or whatever. Okay. If move is t.single move 0, we'll call it single because that's what we call these things. Now, again, if our controller move got killed somehow, we're going to call this flag the same. There's going to be a driven by a controller on each one, right? So if this says driven by a controller something, otherwise it's done, okay? If single dot controller is done, t dot done is true. Okay. So we're just convoluted ways. You could imagine some way of expressing all this more tersely, because there's basically, if you have a move and the first one is driven by it, we're going to say only the one in the first slot. Can controller drive? Yeah, okay. So we're going to say driven by a controller is false, set to true at close time, maybe. What is close time? That's a thing that you always have to call to finalize your transaction. All right. Okay, so that's going to set our driven by a controller flag, if it's there. Okay, our single move needs to have this flag. And we're going to set that back here, if it's a guy only. Oh. Let's set this at close time. For now. We could make this be a thing on the move, and maybe that's better, but let's control the contamination of new variables until we really know. Okay, so if we're going to say if single dot move type is, I can't type today. If it's a linear move and this is move info, and single dot move info dot accel time is greater than or equal to 0. So we're just going to say we're just going to set these. That's like, you know, we could be clearer about this later. Anyway, the last thing we need to do is update guy. So this thing, we're going to say if it's a guy and this is driven by a controller. Okay. Oh, we didn't add controller is done. Okay. So that won't actually fix anything yet because we never set controller is done. In fact, We'll probably never finish our first transaction if everything works. So let's, okay, we walked. And yeah, we're never going back to idle. And as I tap more keys, he just goes crazy trying to finish all his things. That's expected though, because we never set controller is done. So now we're going to set that. Kind of want to delete some comments because this is so messy in here. So these were our old steering conditions. Let's just see if those still work. Hey, all right. So now we still have our extra velocity, but so if I go up, right, we're going to go left first incorrectly, but I still should get to the square because we're not completing our transaction until the controller says we're in the square. Well, oh, right. So we're teleporting to the square because of this thing over here. We're taking the sign distance to the target, which I wonder if we comment this out, then we might be like thrusting all over the place trying to hit the target, and that might not be good. Let's see. Oh boy. Something just broke actually. Well, our sign distance check is necessary. Yeah, you know, okay, here's the thing. Our desired velocity right now, I cheaped out on it. It's just using this. Like in reality, we actually want to use our position. Current delta is wrapped delta manager.proximity grid. Is that? Yeah. Okay, we actually already have that. So, wait. Then that should have been updated. I thought we took that out, but I guess we didn't. Oh, we overshadowed it. Oh, right there. Right there. Okay, we're still taking off down the road. Okay, this is the wrong thing. This is not the sign distance to the target. This is just a victim of being edited too much. Oh, and this is where we started. Okay. There we go. Okay, so now this actually makes sense. So I was taking the original delta which never changes over the course of the move. And you want, like, where is he standing? There we go. So see, he's slowing down a lot in the end, I think, because we're using that in some way. Like, okay. So this is the delta before the move from where the guy is visually to where he's trying to go, right? And then we take this direction, that's the unit vector. That's a little bit of an ambiguous and confusing name. So it's a potential. And so, yeah, this still isn't sign distance. Exactly. Because this is always the same direction as this. Signed distance would be how do we use sign distance? What sign do we want to mean what? Do we even use it? We did down here, right? Except we're never actually using the old sign distance. So maybe we just delete that. Why am I confusing myself with that? Yeah, we just compute the new one, and then we don't even use that one. So like all this stuff is not being used, and this thing is, okay. Let's confuse ourselves less. How does that sound? We're not using that dir variable either, so let's get that out of there. That can go down there. So, does that still compile? Yep. Okay. Okay, so what's our current condition here? We get the new delta after the move from our position to the end. We make it in the xy plane. Okay, so here, see, this is actually not a good condition. Exactly. Okay, there are multiple things happening. So first is we are basing our desired velocity on kind of how much distance is left. So now we're like slowing down, and that's not really good. So we're going to make a thing called we're just going to do that. Now the thing is, if we start with an extreme amount of error, we may damp out We may damp out any lateral correction before we get all the way there. So we're still screwed up, dude. What is going on? How did I mess it up this badly? Oh, because now, okay. So the problem with this condition down here is that it's very easy to overshoot, for example. Like if you go past your epsilon on one frame and you're not slowing down, which we are not, because we took out our deceleration, right? So it's very easy for us to overshoot our little epsilon and then, which I don't even know what this is, but then you'll just keep going forever because we never slow down and we never reverse. Because our desired velocity I mean, here's the thing. I just made our desired velocity again be constant. Like I keep changing my mind about what we're trying to do here, which isn't helping. It's like, oh, I want to correct for weird velocity that we have. Let's make it like unit vector of delta. The problem with this, so this will actually change as we move around. The problem is you could orbit your target with the wrong initial velocity, which is not good, but it probably won't happen. And if it does, we're going to have deceleration and damping anyway, which would prevent you from orbiting, right? Okay, so you have a desired velocity. And then let's put back a very simple deceleration. Let's keep this. And let's put back like, okay, decel dist is O.2. We had something up here, but I don't want to look into it right now. The problem is even something thick like this, you could overshoot at a low frame rate, right? Well, I can just take length of delta. Length of delta, and then speed ratio is going to be distance divided by decel dist. Clamp that from 0 to 1. So now, if we're at 0.3 or more, our speed ratio is going to be 1. Let's make it 0.2. Otherwise, it's less. Okay? And then we're just going to say desired velocity speed ratio. Go speed ratio. So this will slow us down, hopefully in a reasonable way. Okay. So see, we're starting out in some cases with our stupid velocity that throws us off to the side. And then those times when we're like running extra are like our position is correcting by small amounts, but we're still like in the run animation. In reality, what we probably should do, instead of having a controller steer us, we probably should say, hey, there's a little residual position from where we want to be. And you can have an extra controller that just interpolates that to 0 over time, you know? That would probably be smarter. And then that could happen outside the transaction. Because, you know, this is going to look dumb if it's, I mean, okay, so whoa, all right, there we go. We're constantly missing our target. See what I mean? We missed our epsilon back and forth for some reason, which is not good. But also, oh, there it's happening even more. If I slow down time, then we'll recover because the frame rate is effectively higher. So that's not a good behavior. But also, I just don't like, so I'm putting in all this complexity just to handle this extremely adverse situation about starting with all this acceleration, which we're going to take away anyway. So I don't want to do this. I'm going to do the signed distance thing. I'm going to try leaving this in for now, just to get a little correction out of that. That might be a mistake. But we're going to do our signed distance termination clause, okay? And we're going to get rid of this one. So now, okay, we're just going to do the signed distance thing. And if there's a discontinuity at the end, we're just going to fix that with a different system. Because it's going to look dumb to keep him in the transaction and animating. So for now, he'll pop a little bit in these extreme cases. And that popping will, well, he shouldn't have popped that much. Okay, my signed distance is obviously the wrong sign. Okay, wait. From guy.visual position to visual end. Okay, right, it's less, not greater. All right. So now wait, we're not getting the popping. Okay, I guess my changing of the acceleration direction mostly handles that on its own. That surprises me. Okay, so that's pretty good given how adverse of a situation we're giving it. So once we actually reset the velocity to 0, it's not going to be this jacked up, and we'll probably be okay, honestly. He's drunken dude, just wandering around. Drunken. So part of the problem is if you start, see when he was sort of waving up and down there? I can't get it to happen again, but because I'm using your starting position to generate your target velocity, like if you get into an oscillation, he'll stay in it. See? But we could also damp that out after each move. It's pretty easy. Okay, so we have a couple things to do. One of them is uh, once you go to idle, clear out your velocity, and that should be easy. So remember, we were letting it be that crappy because we wanted to make sure the other thing worked all right. So now, here's the place where we decide to idle and whatever. Here. So we're going to say guy.velocity like that. So now that was weird. I guess he had that left over from before. Okay. That was in his save game. Okay, so now we still can get some residual velocity if we're already moving. See, like these curves have a lot, but that's okay. I think we're going to want a little bit of a more sophisticated control where we accelerate differently in the perpendicular direction than the orthogonal or than the parallel. Because you kind of don't want these wide curves. I mean, again, our acceleration time is really longer than it's going to be. But anyway, so you know, turning looks better with acceleration on it like this, though. Except I don't know what those little glitches are. Those might be turning animation problems. His foot kind of goes through the thing sometimes because our acceleration is turned way down. We could turn it back up to a more realistic amount of time, right? Accel time. Let's go 0.2. That just feels better. His foot doesn't go as far into the rock. Oh, we just had a drunken turn. Okay, I need to do an email about what we are doing there. But anyway, the problem that we just fixed is if we're not moving, we will no longer transmit velocity into the next move. So if I go here and then I go up, we just go straight up, right? We don't like start winging out in a curve. We will start winging out in a curve if we do this, but it's a pretty tight one now, and so it's fine. And it looks better because of the movement that's happening, right? So now one problem we're going to have, though, is the rocks still don't match this, right? So they're jumping ahead of me. The other thing that we have is the transaction time. It's a little weird. I feel like we want even a little faster. I don't know why it looks weird and jerky there. That might be an artifact of the new system, like when we're kicking in the animation speed ups or something. I'll take a look at that later. But anyway, you know, so the rock is obviously not synced with the guy anymore. And we don't know when our transaction is happening. We do know it's probably happening too soon. So let's go in here and we'll put in a stupid hack. We have this function called game report. I'm going to say game report move, right? So that'll pop that up on the screen, and we can slow down time and see when that happens, right? So if I'm standing here and I go, it says move. But when does it say move? It should say it right when we cross the middle of a square, but I don't think that's when it's going to be. Like if it's reset so we can see the lines better. We wiped out all the lines. So if I go down, yeah, see it's happening a little early, and that's because it's not accounting for, no, it should be accounting for starting at 0 velocity, actually. Hold on. Let's see what we think about if we're just here and I go left, because this is a very like top-down view onto that line. That's not bad. Because you kind of want it to fire like when the bulk of his body goes into the next square. It feels a little early to me. But not that early. So the thing that it should be late if we're running in multiple squares, because yeah, it's very late in that case, because it's adding the acceleration time. Like we're basically completely in the square when it goes off, because that time computation that we did assumes that we're starting from 0 every time, right? And what we really want to do is say, we could keep see, the problem is our acceleration function is yeah. So basically, instead of our little thing that goes from 0 up to the max speed, we want to go from like a current speed to a max speed, right? So it's like a triangle sitting on top of a block going up to a block. The game engine looks a lot like Dota 2. I don't know. I don't think it looks like Dota 2, but it might have to do with the character proportions or something. The undo is part of gameplay because you need that for solving puzzles. Okay. So instead of 1/2 V1 TXL, it's 1/2. It's 1/2 the average of V0 and V1. Or sorry, 1/2 V0 plus V1 is the average of V0 and V1, right? So that average speed times the amount of time we spend accelerating, right? Plus V1 times the constant time is 1, right? So then we solve for that again. It's going to be almost the same, right? So we get 1 over v1, right? Which is, again, our move time, whatever we said that was, right? Minus, oh, I forgot, we need to do the run speed thing. Bleh. Okay. Minus 1/2 v0 plus v1 over v1. Yeah, so it doesn't, things don't cancel out as cleanly because you can't just divide by v1. In fact, right, instead of dividing by v1, we multiply by move time. Is that right? I don't know, man. PHP RAID, that's not okay. You can't have PHP. That is simply not an acceptable thing. All right, let me double check my math here. Dude, I don't know. So again, we've got why don't, maybe, so the way that I was computing it before, it got a little awkward when I added the constant speed term. And like, maybe we shouldn't be doing it that way. I mean, if I just compute the distance that you would travel while accelerating, and then say 1 minus that distance is the remaining amount of distance that you have to cover. And then how long does that take? That seems maybe more straightforward, but it's probably just turns into the same math, right? It's just we're starting with weird variables that don't make sense anymore. So like the distance you travel while accelerating, right, is, right, your initial velocity times time plus 1/2 a times ta squared, right? And we know a and ta squared. And then, so the time for the move is going to be the acceleration time plus 1 minus dA, which is the remaining distance, divided by the target velocity, because you'll be at the target, or the target speed, because you'll be at the target speed, right? Divided by that. That looks a lot simpler to me. And it's like terms that all make sense. So we have, here's how much time we're going to spend accelerating. There's just a slightly redundant parameter, which is there's the acceleration factor and there's the time that we're going to spend accelerating, right? And those are coupled, right? So yeah, let's just start doing some stuff. So down here, right, we said our acceleration is this. Integrated over time. All right, so we take the target speed, we divide by the time that we're going to take to accelerate. That's our acceleration. Now the problem is, this isn't quite right, because this assumes that we started at a non-zero, or at a zero velocity. So that doesn't matter here, because if we accelerate for too long, we will would just clamp, right? This move toward function caps us at our desired velocity. So this doesn't matter that this is wrong, but it does matter if we try to use this quantity as acceleration in our time estimator, because, you know, we can overestimate. I mean, I guess the acceleration would just be the difference between the target speed and the initial speed divided by the time, right? Is that how that works? I think that might be how that works. But I'm tempted, I'm not going to do this right now, but I'm tempted to just factor this function out and like call it. Because the thing that we're doing right now of like make an equation that estimates what's going to happen is fine, but gets more and more annoying as you start wanting to do more complicated stuff in here. Whereas if we're just like, bro, call it, you know, for 20 time steps and estimate, you know, in a piecewise linear fashion, then it could be any function in the universe and you would get it right, which sounds more robust in the long term, but I don't want to do that right this second. We're gonna put that on our things that we're seriously thinking about doing though, because that would be interesting. Okay, but we're gonna put initial speed in the move info. And we're going to compute that when we set it up. And just make sure this does something reasonable. So here, this is going to be V0. And what's V0? Well, we're going to look at the direction that we want to go. And we're going to say, what's our velocity? In that direction. V0 is dot product dir comma guy dot velocity, right? Which, if he wasn't moving, that'll be 0, because we reset it now. If he was moving, then it could be as high as V1, right? Now, this duration const thing should probably be the get run speed. But we're not going to change that quite yet. We'll change that in a second. Reset. Okay. Well, we didn't mess anything up heinously. Those moves still look late to me, though. But part of that, like, the guy is, like, kind of leaning forward. It's not that bad. I should make a frickin' sound, dude. That's what we're gonna do. Let's find a sound. Like... No, that's not a good sound. No, I want a short sound. Let's go into the braid sound effects. Don't I have like... there we go. Does that... Let's make sure there's no lag at the start of the sound. Let's just really trim it out. It's going to be a little harsh. All right. And then here, instead of game report, we're going to say play sound timer go. Is that even what arguments that takes? Who knows? No. This is when all the autocomplete people say, autocomplete. Rah, 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 rah. Oh, manager. Oh, or an entity. All right. Will people be able to create their own levels? I don't know. Maybe. Feels late. Feels late. Oh, wait, you know, the reason it's late is because we didn't change our actual computation yet. We just made sure our, okay, duh. We didn't actually change. Okay. In fact, this doesn't even do that. This sets the duration of the transaction, which doesn't even matter. We want to estimate the duration until you physically move. Right? Which right now, we're just taking the duration divided by 2. Now, all of this is a little weird. Like, let's harmonize a little bit. So here we're using the target speed, which is V1 which is this gameplay position duration, which makes sense. Except this Excel time doesn't make sense anymore. So the reason we're late, well, the reason we're late on the time when we shouldn't have to accelerate is because we're always adding this time right now, and that's not very good. You know what I want to do? I want to do the serious version. Because there's all sorts of stuff about like, oh, constants, mismatching or whatever. So we're actually going to do the serious SAM situation over here. We're going to factor this into something, I guess. That we can call repeatedly and estimate these things. All right. Sure glad I'm reading chat with all that intelligent conversation happening. All right. So Okay, so this is more deceleration stuff. We have the move info. We can sort of shorten this out. Okay. So this new delta stuff, probably new sign distance just gets returned as the function return value. We're going to delete this for now because we're not using it. Okay. So like if we just have some function, and we're just going to call it. And for now, we're not going to do anything special. We're just going to call it. Right? Okay, we're going to say new visual position sign distance r do guy controller guy visual position single dt, right? And then we're going to factor all of this into that, right? We're going to say do guy controller. What were our parameters? Do guy controller. Going to do all this. All this. This is even going to, oh no. We need this velocity. Okay, so do guy controller return position new sign distance, right? And then we need the entity manager. Okay. Okay. So we're just going to call this a bunch of times. And then this old function is almost doesn't do very much. It just calls it with things pointing, whoops, like that. And then This can go here. And this could even go here. Okay, we probably screwed some stuff up. Do guy controller. Oh, we forgot to return our things. New visual position is a vector 3, and assigned distance is a float. All right, and okay. Position. We called this pause. Sometimes I get the urge to abbreviate, and then I regret it later, so we're going to unabbreviate. Oh. Right. This needs to be a pointer. Because we're going to continually move it or modify it. All right. Oh no, we're not going to modify it, right? Duh. Like, it's weird because we're modifying the velocity inflate. We could return the velocity, like. All right. Okay. So if we didn't screw things up badly, we won't have any improvement, but we'll still be able to walk around. Oh boy, we screwed it up. Okay. Oh, because we're not setting his visual position. So that's very bad. Okay. Okay, still, you know, no real improvement. If we slow it down, we're still going to be, late on this one, right? Yeah. We don't want to be that far in the square when we do the move because we haven't changed anything yet. Okay, so now I want to do the weird ass thing where I say estimate we're going to say estimate estimate physical move time or duration. And we're just going to say dt is 0.05. Steps max is 100, right? So that's 5 seconds. Shouldn't take 5 seconds, right? And we're just going to iterate. This is going to be slow and stupid, and we don't care because we want flexibility. We're going to say for duration is 0 for 1 to steps max. If signed distance is less than 0.5, break. Cleanup, we could estimate more accurately by sub-time step interpolation. Right? So we're just going to stop when we've counted enough time that we would get past the halfway point. But like, we're not trying to be too accurate about how far past it we went, right? Okay. I mean, let's just go to 300. We should never get near steps max, so whatever. Okay. We don't actually want to change this. And honestly, let's do the velocity thing because we don't want to mutate his velocity either. Because the point of this, it's like you're in the Matrix. It's not the real world. We're just simulating what the move's going to be. Okay, so visual position, velocity, right? And we're going to return new velocity and visual position and velocity is new velocity. I could have just assigned them up here, but whatever. Okay, and then return duration. This is going to return a float. And let's just go make this do the right thing now. New velocity, right? And we're just going to pass these in. Guy.velocity is new velocity. Do guy controller. New velocity is a vector 3, right? And then this is not velocity pointer. This is velocity raptor. That's a good name for a physics engine. Okay, so we're still not actually doing this. We're just making sure we didn't break anything. Okay, great. We can still run around. Okay, now we're just going to call this estimation function when we do that closed transaction. Here, when we decided we're driven by a controller, we're just going to call this function. We don't actually care. And actually, yeah, this does have to be a guy. So we're going to say, so the single move should have our ID, right? Yeah. Manager single dot entity ID if e guy and e guy dot entity type is guy, not googie. I should make a shortcut function for this, but I never do. I don't know what's going on. So we're going to do this, and we're going to do some estimation. We're going to say duration is estimate physical move duration. Let's call it estimate of guy and if guy. We're going to estimate the physical move duration of guy, this move, right? And we're going to print. You're going to say game report tprint estimate is whatever, comma estimate. All right. Let's just see what happens. Okay, we're getting estimates of 0. That's not good. That is not going to help us. Oh, and you know what? We actually need to copy because don't we mutate stuff in the move? I mean, that's not the problem right now, but what do we use? No? I guess we don't. Okay. We're going to make a debug build and just go in there. Movement, visuals. Okay. Bam. Because, you know, probably we just did something stupid. Okay. So. Oh, we don't actually add anything to the duration. I hope somebody caught that. Somebody did. Thank you. Of course, it's going to be 0 if you set it to 0 and then don't do anything. Okay, see how it's shorter? It's shorter now when we're running. Now it's only 4 time steps, so I would say we're not getting a very accurate. So it's shorter when we're running, and it's longer when we have to flip around. See, it's 0.35. So let's make our time step shorter. This is like 20 FPS. Let's just loop. We're just gonna loop like free people. All right, so we're not using the estimate yet. So we're still going to be late. But let's see. What we want to see is that this is early. Right? So down here, we figure out the duration until the physical move. All right? We're going to have to hook these things up. Let's just put this down here for a second. So now we're going to also print, what we think it should be versus what it's actually getting set to. And hopefully it's going to be lower when we're straight running, right? There we go. See? It's not that much lower, but it's like... It's substantially lower. It's like more than 10% lower. And it would get lower if we estimated more accurately anyway, right? Yeah, and then in the cases when we turn around, it's like later, but that's correct. Okay, so now this whole thing, if we're driven by a controller, we want the controller to determine Okay. Okay, so in here, we're going to say, see, the trick is, if there's like a teleport happening or something, the physical moves really need to be soon. But otherwise, yeah. Okay, so here we're going to say, there. And then ignore max duration, since that is determined by the controller completion proc. Okay. So yeah. So we're going to set that here. And then here we're going to say there. Anyway, so this is us computing a duration until physical move that could be overridden if there's like a faster action happening later in our transaction, which for what we're testing right now is not a thing, but later it'll be a thing. This already looks better. Let's see. Better. Way better. See, he's still across the line a little bit, but it's because he's leaning forward. Oh, my versus is now not good because we're doing it before we compute that, but this is pretty good, honestly. So again, for people tuning in later, the beep is when, for gameplay purposes, we consider him to have physically moved into the square where he's going into, right? So like if something would kill him on that square, for example, that's when he would die. You don't want him to die too soon. You don't want him to die too late, right? It's actually still a little late, honestly, but it depends. It's pretty good, though. It sort of depends on what angle you're looking at it. But yeah. It seems bad when going left. Well, I think it's just the camera. Like, it just looks different because of the perspective. We could go to a map that's a fully overhead view. Whoops. Like, oh God, this has a ton of characters right now. So let's just have this guy, and we're just going to change the camera for now to be like that. This is just my level that I always screw around with. Uh-oh. We already broke it. It's probably something to do with the lily pads. All right. Oh, no, now we're beeping. The lily pad is beeping us, which we don't want. Oh, that was weird too, because it was loading some save game state from before I added these extra things. So yeah, it's a little bit late, probably because of the visual lean, like how he leans into the square, but we can add a constant factor to offset that. And again, we can also improve the accuracy of our estimation method. In theory, it should beep when the guy's berry center is at the center of the square. No, that's too late. It should beep when he's crossing the line from one square to another. Like here. Now you'll notice, so the root for these characters is like in an idle pose, the root would probably be between their feet somewhere, right? Like it would be like there, right? And so if you watch for that, you know, I mean, the thing is, when you animate the guy, his feet move away from the root bone a little bit and stuff, whatever, but it's a good approximate guideline. So like about when the point between his feet crosses the line, you know, there one foot was dragged way back, but like that's fine because we're not, you know, but you see what I'm saying, right? It's about as close as you would expect for something with like a lot of visuals. Yeah, on the big step there, his feet aren't across yet, but that's fine because his body's way across and you want that. So there's other stuff we have to do. I'm actually going to end the stream because I got to go to work. But I'm glad that we did that. When I had the idea to do this today, I was like, oh, that's going to be overkill and stupid. But it's actually a good idea because now we can put whatever we want into this function and it'll be fine. And we won't have to worry about doing redundant and slightly different math and keeping it up to date all the time. We're not using the run speed thing that we used to use. We need to add back in the character deceleration. And we want pushing. We want pushing to sync back up, right? So like if I push this guy, he's not really synced with me anymore because he's just doing a linear interpolation. So there's that. And then also pulling, right? So, well, that was a teleport pull, so that's different, but. Yeah. See, pulling is not synced up either. So for stuff like pushes and pulls, in a controller-driven animation like this, we're going to want to sync them. So that'll be next stream. But we're getting there. New system could help with animation timing and enemy attack happening mid-animation for a bad move. The feedback would be pleasant. Yes, I mean, that's part of the reason we're doing this. So like if there's a monster somewhere and the game thinks you went into the square way too soon, then it feels stupid. It's like, wait, I was way far away from that monster and it still killed me, right? But also in terms of timing levels, let me try and remember, just so I can show you one of the reasons why I'm working so hard on this stuff. Let me try and remember the name of this level. There's, you know, we do, the way that I do games is the basic system works for 90% of the things, or 95%, but then for the extra 5%, I do a lot of extra work. It's more like extra 10 or 15% in this game, but what's it called? Rotating cavalry spaced. All right. Whoops. Not Spaceyed. Not Kevin Spaceyed. All right, so this level, you can't see the river very clearly, but there's these dragons going by on the side, and they will toast me if I'm in the wrong place, right? Now, those beeps are happening because they're moving with the same kind of transactions that I'm moving. And so to like solve this level, I kind of have to go out. Well, we didn't draw the particles very well that time. But the point is, I'm kind of racing these guys, right? Whoa, that was kind of wrong, actually. There, okay. I kind of teleport skipped. You've got to wait till they're in like the hole where you're going to go and teleport skip over them. Except that was weird because my teleport, it's still kind of unplayable because, okay, there's a problem. There's definitely a problem. But you see how this kind of level gets unplayable. Like if things move way too soon or way too late than you think, you can't really dodge the stuff in your head, right? So now there's clearly some kind of a problem here. It probably has to do with the guys riding on the lily pads, honestly. It looks like it's happening at about the right time. So I don't know where the weird particles were coming from, but we're going to have to debug this with like one dragon. Anyway, the idea is you just keep doing this. Maybe it's just the visual feedback is bad when I screw up. You keep doing this, and then you grab the thing, and then you rotate it, and now they all die. And of course, all those visuals have to be made to work better with the new transaction system. But yes, it is an annoying sound. So the point is to make levels like this work well. And there's a lot of complicating factors. There's like the lily pads are moving on a certain timing. They're carrying the dragons. The dragons have like long range death beams. And you teleport and like all this stuff, right? So yeah. So like all that has to work together to make a level that not only like functions, but feels good. That's what we're working toward with this new movement system. So there seems to be a fundamental bug there in some way. I'm hoping it's not too bad of one. And we'll see. But we're making good progress. We're making good progress. With the previous movement system that we are replacing, this level was totally unplayable. Now I just managed to play it, except that there seems to be a weird problem. So it's in better shape. We will continue to shape it up. But, okay, so we're going to restore the run speed variables that we took out next time. We're going to make things synchronize when we push them. And we're going to put deceleration back in on the character movement. And that'll be pretty good. And then we'll try to debug this level. What's this? Rotating cavalry. And then, who knows? The new water stream is very nice. Yeah, that's temporary. It's going to be a lot cooler. When, where would the particle effect origin go considering the new system? Well, it would just be attached to whatever your visual position is, probably. I don't know. We figure that out. Like the particle effect when the dragons breathe right now is pretty weak sauce anyway. So we'd have to build that into a better effect and then see what it's like. All right, let's see if we could raid somebody. Let's see. Let's see who's doing science and technology today. What's going on? Daily to-do list. That sounds exciting.
I'll need an area that's like a.
Let's do that. All right. Thanks everyone for coming by. And I'll see you later. Daily to-do list stream. Super exciting.